Tor Browser has a fingerprinting bug that links every identity you've ever used, not across sessions, not probabilistically, but with a stable, persistent identifier that survives new circuits, new tabs, and new windows. That's the claim from Fingerprint.com, and before you dismiss it because the source has an obvious commercial interest in fingerprinting technology, the technical details they published hold up. Here's what's actually happening. Firefox maintains an IndexedDB database for internal browser state. That database gets assigned a UUID, a unique identifier, when Firefox is first initialized. The problem is that Tor Browser, which is built on Firefox ESR, was not isolating that UUID per identity context. When you open a new Tor circuit or a new identity via the New Identity button, the browser's internal IndexedDB UUID persists. Any page that can read it, and reading it requires no special permissions, no exploit, just a normal web API call, can correlate your current session with every previous session you've had in that browser installation. You thought you were compartmentalized. You were not. To be precise about the scope, this is not a remote code execution vulnerability. There's no CVE assigned, yet as of the time this research was published, though one is presumably in flight. This is a privacy regression, a tracking identifier that should not exist, exposed through a browser API that was never supposed to surface persistent state across Tor identity boundaries. The Tor project's entire threat model depends on the assumption that new identity gives you a fresh, unlinkable context. This breaks that assumption at the storage layer. The mechanics matter here. IndexedDB is a browser-side key-value store, part of the web storage APIs. It's been in Firefox since version 16, it's in every modern browser, and it's primarily used by web applications to store structured data client-side. Think offline-capable apps, PWA, that sort of thing. Firefox also uses it internally for browser state. The UUID in question is not something a web application wrote there. It's something Firefox itself created and stored. The issue is that Firefox's first-party isolation and state partitioning, which Tor Browser relies on to separate contexts, was not applied to this particular internal database. The identifier sits in a shared namespace that all browsing contexts can read. Fingerprint.com published a proof of concept. The read is straightforward. Open a connection to the relevant IndexedDB store, read the value, done. No elevated privileges, no browser extension required, no social engineering. A normal web page running normal JavaScript can do this. That's the operational severity here. The attack surface is any website you visit. Now, who actually cares about this? If you're running Tor Browser for casual privacy, you don't want your ISP logging your traffic. You're in a country with aggressive network surveillance. This vulnerability is serious, but the threat model adjustment is specific. Your ISP still can't see your traffic. But any website you visit, if it's instrumented to read this identifier, can now link your visits across what you believed were separate identities. That's a significant degradation. Journalists using Tor to communicate with sources from the same machine, activists using new identity to compartmentalize different operational contexts, security researchers doing recon from a shared browser installation, all of these people have a problem. For the average engineer who doesn't use Tor personally, the immediate operational impact is low. But there are a few adjacent concerns worth thinking through. First, if your organization has any tooling or internal guidance that points to Tor Browser as a privacy-preserving research tool, for threat intelligence work, for checking how your own infrastructure looks from outside, for anything involving operational security, that guidance needs a footnote right now. Second, this is a reminder that browser state isolation is much harder than it looks. Tor Browser has a dedicated team whose entire job is finding and patching exactly this class of issue. They missed this one for an unclear amount of time. If Tor's hardened Firefox build can have a persistent cross-context identifier hiding in an internal database, your assumptions about browser isolation in other contexts, incognito mode, container tabs in Firefox, separate Chrome profiles, deserve similar skepticism. The Tor project's response has been to patch this, and the fix is in Tor Browser version 14.5. 1. If you're running anything older than that, you have the vulnerability. Update immediately. That's the single most important action item in this entire story. Let's talk about what this means technically for the fix. The correct remediation is to either regenerate the UUID on every new identity invocation, or to scope the UUID to the current identity context so it doesn't persist across identity resets. Fingerprint. Com's write-up suggests the fix involves clearing or regenerating the relevant IndexedDB entries as part of the new identity flow. The deeper fix is ensuring that Firefox's internal storage, not just web origin storage, is subject to the same isolation guarantees that Tor Browser enforces for everything else. This is a category of bug that's hard to audit because internal browser databases aren't documented the way public APIs are. You need to know they exist before you can check whether they are isolated. There's a broader pattern here that's worth naming. Browser fingerprinting research has gotten extremely sophisticated over the last 5 years, and a lot of the interesting findings come from companies that sell fingerprinting as a service, Fingerprint, Com being one of the more prominent ones. They have an obvious incentive to find and publish these vulnerabilities. It validates their product, it gets them press coverage, and it demonstrates technical depth to potential customers. That doesn't make their research wrong. The UUID finding appears to be real and reproducible, but it's worth reading their disclosure with the awareness that they are not a disinterested academic lab. They are a company whose revenue depends on browsers being trackable. When they find a bug that makes Tor Browser more trackable, they benefit from publishing it. The ethical move, which they did take, is responsible disclosure before publication. But the framing of their blog post is inevitably going to emphasize how powerful fingerprinting is, because that's their product. The Hacker News thread on this hit 850 points and 254 comments, which for a security story is substantial. The discussion is worth reading. Several commenters raised the question of whether this was known to adversaries before Fingerprint. Com published it. That's unknowable from public information. The Tor project hasn't said when they were notified or how long the disclosure window was. Unclear from the reporting. One commenter in the thread made the point that this is specifically a Tor browser issue, not a Firefox issue for general users, because the threat model is different. That's technically correct but slightly misleading. General Firefox users don't have an expectation that new identity resets their browser state, because general Firefox doesn't have a new identity button. But the underlying issue, that Firefox's internal IndexedDB stores a persistent UUID that is readable by web content, is a Firefox issue that Tor Browser inherited. Whether Mozilla considers it a privacy bug in mainline Firefox is a separate question. If you're using Firefox with container tabs and expecting strong isolation between containers, you should be asking whether this UUID is also readable across container boundaries. The research doesn't directly address that case. The concrete takeaway is this: update Tor Browser to 14.5.1 right now if you or anyone on your team uses it for anything security sensitive. If you maintain internal documentation or runbooks that recommend Tor Browser as a privacy tool, add a version pin. And if you're doing any work involving browser isolation guarantees, whether that's security research, privacy engineering, or threat modeling for a product that relies on client-side state separation, this bug is a useful case study in how internal browser storage can silently violate isolation boundaries that the rest of the system is trying to enforce. The lesson is not that Tor is broken. The lesson is that isolation is a property you have to audit at every storage layer, including the ones the browser itself creates.